Ну, там тишина. Там тишина, я не знаю, там. Ну, я же их попросил что-нибудь сказать. Hello? Is anybody here? Can you hear me? Hello? Какие-то дети там. Hello? Ну, как понять, что я для кого-то рассказываю?
У нас работает.
У нас работает.
Да. А они просто не включают микрофон. Ну, ничего не. Ну,
Hello? I just want to know if somebody hears me.
I can hear you.
Hello? Perfect. So I will start for you, okay?
Yes, I can hear you.
Great. Well, this is UVM10 unit. This is typical digester, and I'm gonna show you operational principle and design of the unit. In order to prepare you for commission of units like this, okay? So UVM10, typical degasser. Let's go through the design from the very beginning. The unit actually starts here. Here we have ports for inlet and outlet. Here you can see the hoses, your inlet and outlet. As a rule, the hoses are not supplied with the unit, so the unit actually starts here from fast joints, cam bolts, and the hoses for inlet and outlet are already fitted in here. So inlet line, then manual valve, then mesh filter. Usually it has the size from 200 to 500 microns. Then oil goes through the mesh filter to the inlet pump. It's over there. As rule, a centrifugal pump is used. This one is from Pedrola. And this is inlet pump. What else I want to show you in the line before the pump? Here we have the sensor. It's over there. It detects the oil and stops the operation of the inlet pump if no oil is detected on its inlet. So this is to prevent running inlet pump without oil. And also I want to show you the port. Again, it is on the inlet line. After the mesh filter, we have the port where usually moisture sensor locates when the unit equipped with the moisture sensor. So centrifugal inlet pump, then the valve. This one is very important if the unit is manually controlled, if capacity of the unit is manually controlled, like we have in this model. So with this valve, we control the capacity of the inlet pump. So it is quite important. Then oil goes to the filter, but here we can see the port for the pressure gauge. It goes here. Then we have the fine filter. The fine filter. Then we have another port for another gauge. So for each filter, we have two gauges. One at the inlet of the filter, second one at the outlet. So by the differential pressure on these gauges, we can judge about the state of the filtering elements. So fine filter, usually it is 25 microns, but again, any size can be supplied according to client's requirements. What we have in here also, here we have the draining point to drain oil while servicing of the filter. Here, the magnets are placed. So periodically, the operators should take all this part and clean the magnets. So this is where the magnets are located in the filter. So after the filter, oil goes to the bottom of the heater. Heater in this design located in separate vessel. It has total capacity of 150 to 180 kilowatts. We have 3 sections of the heater. So each section has capacity of from 50 to 60 kilowatts. So 3 separately controlled sections of the heater. Altogether, it makes 150 to 180 kilowatts. Then what we can see, there is the temperature sensor and the thermostat. So normally it has setting like 80 to 90 centigrades. So oil after the heater goes in this line. Let me show you. It comes here from the heater. It comes here, and here we have the flow sensor. So this sensor detects the presence of the flow and controls the operation of the heater. When there is no oil, operation of the heater is interlocked. Then here we can see the split point for the flow. First one is for the heating and filtration mode. This valve is closed. This one is open. So oil goes after the first filter, fine filter, after the heater, through the flow sensor, it goes to the second fine filter. It's over there. So oil comes here and finally goes out. So this line is used when we work in heating and filtration mode. So no drying is applied to the oil. We just use this oil to this mode to transfer oil or to heat it or to flush transformer with hot oil. That was about heating and filtration mode. Now, if we close this valve and open that one, oil will go to the vacuum chamber, through the cutting of valve. So normally it is closed and it opens when some pressure provided to its inlet here. So if sufficient pressure applied to this point, the valve opens and lets oil come into the vacuum chamber. So pressure in here provided by operation of the inlet pump. So if pump works, it provides pressure on this point of the valve, and it makes the valve open. So oil finally goes into the vacuum chamber. This valve is used to prevent uncontrolled filling of the vacuum chamber, since here we have a low pressure and oil will be sucked by itself into the vacuum chamber. To prevent uncontrolled filling of the vacuum column, we use this cutting off valve. So oil comes into the vacuum chamber and it goes through this system, which is used to distribute oil onto the maximal surface. So this boosts the surface, actually, process of evaporation and degassing. So this is so-called filter activator or sprayer. So we distribute oil onto the maximal surface, and by means of this, we boost the efficiency of evaporation and degassing. So here we have the start of the vacuum line. This is the vacuum cutoff valve, and from here, vacuum line starts. Then it goes Then it goes to the oil trap in the vacuum line. Here at the oil trap, we can see an oil sensor. If some oil is captured, excuse me? Hello? Can I continue? So here we have the oil trap and the oil sensor. If the sensor detects oil, it's
Play.
ну, у меня какие-то звуки там эти звуки. Может, ты себе возьмешь второй микрофон?
Будет переключаться микрофон и будет тебя плохо слышно.
Ну, что-то там квакало, как страшно. Okay, let's go. Oil trap, oil sensor. If the sensor detects oil, it stops the operation of the unit. And the operation can be resumed when we drain oil from the trap. By the way, from this point, oil from the oil trap moves to this vessel. And from here, you can drain oil at any moment with no interruption of operation. You can see the level of oil in here, and by cutting off of the vessel, you can drain the oil captured by the vacuum system. Then close the draining valve and open it again, and to wait until more oil come in here to drain it again. So this is to remove oil from the oil trap with no interruption of the process. Now, vacuum system consists of booster pump. In here, the capacity of the pump is 2,000 cubic meters per hour. This is booster, the roots type pump, and Here you can see two vacuum pumps. It's a rotary wind pump with capacity of 100 cubic meters per hour. Sometimes the unit is supplied with 3 pumps, sometimes with 2, and it also can be supplied with 1 pump, but with a total capacity not less than 200 cubic meters per hour. So here we have 2 of 100 cubic meters per hour. So what about the vacuum system? Let's go back to the vacuum chamber and we'll see where the oil goes from it. This is uh, the outlet pump. Again, this is centrifugal pump. So it takes oil from the vacuum chamber and through the non-return valve, it passes oil to the fine filter through this valve. Can you remember I have told about this one? This valve is used to control capacity of the inlet pump. And finally, we have this valve to control capacity of the outlet pump. What is important while operating the unit? We should balance the capacity of the inlet and outlet line. So with these two valves, we adjust the capacity of the pumps and would balance system. So the flow on the inlet is equal to the flow on the outlet, and this is the right way to work with this unit. It is quite important. So through this valve, oil goes to the second fine filter. Again, you can see the port for the gauge, pressure gauge in here, and this is the gauge before the filter, and this one after the filter. And we can see it here. This is the port for the gauge after the fine filter. So it was about the common design of the unit. Now, a few words about the sensors on the vacuum chamber. We have actually 4 level sensors on the vacuum chamber. Let's start from the bottom one. Difficult to show. It's over there. So this sensor controls the operation of the outlet pump. So if no oil is detected by the sensor, the operation of the outlet pump is interlocked. Again, this is used to prevent operation of the pump without oil. If no oil is detected by the bottom level sensor of the vacuum chamber, outlet pump cannot run. Then we have 2 sensors on the top, and they control operation of the inlet pump. So if oil is detected by the top sensor, it stops the inlet pump, and inlet pump starts again when oil level drops down to this middle sensor. If level goes lower than this sensor, inlet pump starts again. To say truly, we have a little bit different method of inlet pump control. We also use the following procedure. If oil goes lower than the top sensor and we detect the absence of oil during following 10 seconds on the top sensor, the inlet pump starts. So we have 2 methods of inlet pump control. We use 2 sensors top sensor and middle sensor to stop and to start inlet pump again. Or we use the top sensor only. If oil is detected by the top sensor, inlet pump stops and it starts again when there is no oil on the top sensor longer than 10 seconds. Okay, this was about the level of sensors controlling the operation of the oil pumps. We also have the foam sensor in here. If foam is detected by this sensor, the system automatically opens solenoid valve, which is over there. It is in the vacuum trap. By means of this, we raise pressure inside the vacuum chamber, and in this way, we fight foaming. So, if foam sensor detects foam, it opens the air inlet solenoid valve, pressure rises, and foam level decreases. It is done automatically. Now, about other sensors. We have vacuum sensor. It's over there. So by means of the sensor, we control pressure in the vacuum line and in the vacuum chamber. It also controls the turning off and turning on point of the booster pump. The booster pump starts when pressure is lower than 10 millibars. This setting is done on the controller of the unit. So I guess we have seen all the sensors, and the last one is the floating sensors. It's over there. So if some oil spills in the tray of the unit, it will fill this hole, and it will make the floating sensor to go up. And this is the critical alarm. If the sensor is on, the operation of the unit is stopped. Now, about the control system. This is how to turn it on. So here you can see the controller. And the buttons for operation of pumps. Inlet pump, outlet pump, vacuum pump 1, 2, and booster. And as I have said, we have 3 sections of the heater. These are the buttons to operate heater, booster, vacuum pumps, vacuum pumps, oil pumps, inlet and outlet. Also, we have here the button for vacuum discharge. This is this is used for forced opening of the inlet air valve. Yeah, here at the mnemonic diagram, you can see this valve. So it goes in the oil trap, and finally air comes in the vacuum chamber. So if I press this vacuum discharge button, it opens this valve. Now there is no vacuum inside the unit, so you can't hear any noise. Now above the mnemonic diagram here, LS4 sensor, the one before the pump to prevent operation of the pump with no oil. Then first fine filter, then heater of 3 sections, then thermostat, PS flow sensor, and here is the line for the gassing process. We can see here 3 level sensors controlling operation of oil pumps. Then outlet pump, sorry. The second fine filter and the outlet. Also, we have the line for internal circulation. This is quite important because this is the part of the starting procedure of the unit. After the first filling of the unit, we warm up the unit by circulating oil from the vacuum chamber by the outlet pump through the bypass valve, through the inlet pump, through the filter, through the heater, back into the vacuum chamber. So this internal circulation allows to warm up the unit and to prepare the first portion of oil. Now I want to show you this valve, MV5. It is over there. So we open it to arrange internal circulation inside the unit. The internal circulation lasts until we raise the temperature inside the unit up to the set value. Normally it is 55 centigrades. And pressure inside the vacuum chamber should be lower than 2 millibars. So internal circulation supposed to be finished when we reach this temperature and this pressure. And while this process, we prepare the first portion of oil. If we get these parameters, I mean temperature and pressure, we can start treatment of oil from external tank. So we can open inlet valve, start the inlet pump, to let oil in, and to open the outlet valve to let oil out. And after internal circulation, we can treat oil from external tanks. Now about the mnemonic diagram. We have also buttons for, not buttons, but lights. Lights for braking pumps, for the booster, for the LS5 level sensor in the oil prep, and LS7 sensor for oil spillage, this floating one. Okay, now let's see the controller. Let's see the readings on it. At the first line, we can see the current temperature and the state of the heater. So now it's 17 centigrades and heater is off, of course. TG 400 millibar. So in the second line, the current vacuum value is indicated. Now it indicates 400 because this is the top limit of the measuring range of vacuum sensor. Now P1, and this is inlet pump. The state of it is off. The same about P2 pump. The outlet pump is also off. V1 pump is off now. P2. Here P2 is actually booster pump. It's also off. And we can see the state of level sensors. L1 is the top sensor, and the oil is higher than L2. And also we have L3 sensor on. in the vacuum chamber. And L4 sensor is the sensor before the inlet pump and current date. So also by means of controller, we can change the setting for operation temperature. To do this, we press F1 button. Here we can see oil temperature setting, and with F3 and F4 buttons, we can raise or decrease the setting of the temperature. By pressing F1 once again, we go to the setting of booster activation once more. Repeat the booster activation pressure setting. Now it's 10 millibar. Again, to change this value, we can raise or decrease by F3 and F4 buttons. Okay. Now, about this starting procedure and commissioning, it's very important to prepare the field for it. I mean, for to start the unit, you need to arrange the proper electrical connection, availability of the cable. It is quite important because the total capacity of this unit is something like 180 kilowatts. So to run the unit on the full capacity, you need cable of 4 wires, each of 150 square millimeters cross section. So it should be quite a huge one. Here I have the cable of 35 square millimeters, 4 wires of 35 square millimeters. And this is enough to start with one heating section only. So while commissioning, uh, 35 millimeters cable is enough to run with one heating section only. So with this one, you cannot run the unit on the full capacity. But sometimes while commissioning, it is okay to run with this with one heating stage only. You actually can change the heating to show the operation to the client. Let me show you. So we have the switchers for each section of the heater. They are here. So you can activate all 3 sections of the heater to see the algorithm of heating operation. But if you work with 35 square millimeters cable, keep in mind that only one section should physically work. So you can choose any of them. You can choose the second one or third one, but if you work with such a small cable, keep in mind that you can only run one section of the heating. Now, about the commissioning concerning the hoses. The hoses shouldn't be very long. I mean, not longer than, let's say, 20 meters, because if the hose is too long, it will probably limit the operation of the inlet pump, and you will not be able to show the productivity of the unit. So keep in mind that you should have the hoses of sufficient diameter. So here it should be 50 millimeters of diameter, and they should be not very long. I mean, the tank with the oil you're gonna treat and the unit should be as close as possible. And once again, if you work now, I run the unit with this tank. It's quite huge. I have quite a lot of oil in here, and for letting oil in the unit, it is enough to open the air bleeding valve on the mesh filter and to wait until oil will go by itself. But sometimes the oil level is low, and to take oil in the unit, you can use vacuum. To do this, you vacuumize the vacuum chamber and open this valve. By opening this valve, you also vacuumize the whole inlet line. So actually, we have vacuum on the very inlet of the unit by opening of this valve. We open the valve in here, and it allows us to bypass. This is the other end of this hose, and this allows us to bypass this cutting of valve. Then we open the valve in here. So we vacuumize these pipes. Finally, we vacuumize line with the heater, with the filter, and we get vacuum in here. So if we have vacuum in here, we can take oil from the tank with a low level of oil. So by means of this, you can fill the unit. After filling of the unit, you perform the internal circulation in the way I have already told you. So at first we fill the vacuum chamber with oil, then with the outlet pump, by opening this valve, we arrange the internal circulation and wait until the temperature inside the unit will raise up to 55 to 60 centigrades, and pressure in the vacuum chamber goes lower than 2 millibar. After that, you can start treatment of oil, taking it to the inlet and passing to the outlet. Another thing, sometimes while commissioning, we work with the tank like this. And in here, it's quite important to prevent bubbling inside this vessel. Let's say you take oil from the bottom and pass it back through this hole, and oil coming down captures air's bubble, and these bubbles are taken again by the inlet pump, and it will cause significant foaming inside of the vacuum chamber. So make sure that you do not mix in bubbles, air bubbles, by the outlet flow. The one mod I forgot to tell you about is the external equipment minimizing mode. With this, from this port, we can connect any external equipment with the hose, and we can evacuate some external tank. So this is done while, let's say, filling of transformer with new oils. At first, the transformer is vacuumized, and after that, it is filled with oil. So now I guess we went through the design, we went through the operational principle, and starting procedure of UVM 10. That was what I wanted to tell you today. Please ask your questions, and thank you for your attention.
Yeah, so I do have a question. So this is the manual system. What would be some of the differences